This is a short tutorial to get you started with LTSpice. To download LTSpice, Google LTSpice. Go to the link under analog.com and download the relevant version for the operating system that you are using. Once the download is completed, just execute the file. It's a straightforward process. I'll leave this part to you because I've already installed, but if you have any trouble installing the software, please email me. Once you have installed LTSpice, you can start LTSpice from the Start menu. This is the first screen that you get. So essentially, the main toolbars that you'll be using is around this area where you'll have all the components and all the editing properties that you have. To start a new schematic to simulate a circuit, you can go to File, New Schematic, and you'll get this gray background. So for this tutorial, I'll create a very simple RLC circuit, a second order circuit, and I'll apply a step function to see how the transient response is. So to get an RLC circuit, I'll get a resistor. You can rotate the component on the background by pressing Ctrl R and then click on the screen to place it. Press Escape to come out of that placement of the resistors. To zoom in and out, you can use your mouse scroll button. Next, I'll get an inductor. Same thing, Ctrl R to rotate. And a capacitor. And to simulate the step function, I will use a switch, which you can get from this icon here, component. Scroll down to part where you see an SW. This is a voltage control switch, so you'll have to apply a pulse or certain type of voltage source to control it. I'll show how it's done later. Finally, you need power supplies. I'll need one for the voltage of the actual circuit that I'm simulating, and another one to control the switch. Next, you can wire them up by using the wire button here. Just connect the nodes of the components that you have. Next, you need to make sure that you ground the circuit, so you can get the ground from here. Another one here, and another one there. So for our circuit, I'll set when you need to simulate a circuit, you need to give values to the elements that you're using. So when you want to do that, go over the element that you want to change the value for, right click it, and you'll get a pop-up window with options for you to change. For this example, I'll use a 40 ohm resistor, a 1 millihenry inductor. Just right click it, and a 0.1 microfarad capacitor. Next, I'll use a 1 volt DC supply, and to simulate a step function, I'll use a switch that gets turned on at the start of the simulation. So what I'll need to do is to get a pulse that actually turns on at the start of the simulation. Right click the power supply, you get this pop-up window. Next, click on Advanced, and you get all this additional, different types of power supply that you can use. What I'll use is a pulse, and you can set the initial value to be 0 and the on value to be 1 volt. 0 delay. You can set the rise time to be 1 nano, fall to be 1 nano, and you can left the T on for 1 second. Next, the switch has its own set of properties that you need to set. First, you can name the switch so that you can refer to it in the SPICE code later. You do that by double clicking the value button, and I'll set the name as RLC switch. Once you've done that, press the letter S on your keyboard, and you should get this SPICE directive pop-up window where you need to type in the properties of the switch. Set the property of a switch, you type model, the name of the switch that you gave, and you set the property of the switch. That's the default. SW is the default identification for the switch, and there's 4 things that you can set for the switch. But for our simulation, we will set the resistance when it's turned on to be 1 ohm, when it's off to be 10 meg, and you need to set a threshold voltage for the switch. In our case, I'll set it to 1 microvolt. Click on OK and place the text somewhere along the screen. Next thing you need to do, once you have all this set up, you can start the simulation. But before that, you need to set the parameters of your simulation. Go to Simulate, Edit Simulation. For this simulation, I will run it for half a millisecond with a maximum time step of half a microsecond. This is so that you get 1,000th of the runtime. And since we are actually exploring the transient response of the circuit when you apply a step function, you need to make sure that you define the initial condition of all the nodes. So in our case, in this particular circuit, the initial conditions will be 0 because this is not connected. The switch is open before you start the simulation. So you need to make sure you press skip initial operating point solution. Once you've done all that, you can start your simulation by going to Simulate and run it. So once it's run, to get the graph of your voltage across the capacitor to see how the transient response is, you can place the cursor close to the node and you'll notice that your cursor changes to a probe. Left click on it, and that's your step response of your RLC circuit for this particular values. Now you might want to analyze the circuit analytically and derive an expression for a circuit. So I've done what I need to do for mine, and if you want to plot the derivation that you've obtained in this plot here, right click on the plot, click on add traces, and you can write the equation or the expression that you have obtained. So for this circuit, So time is the X scale. Now, in LT Spice, the expression for the sine has to be defined in terms of degree, not radian. So for that, I will be changing this into a degree by multiplying with a coefficient. So this is the expression I got based on using circuit theory on the circuit that I've designed. Down here, it would differ based on whatever circuit that you're going to be analyzing. So keep that in mind. So once you have included the expression, click on OK, and you'll notice that the derivation that I've done actually matches the actual simulation that I've obtained from LTSpice. So once you have plotted them, you can see how well they actually match together. And if you want to export the data that you've obtained from here, you can do so by right-clicking on the graphing area, click on File, go to Export Data as Text. So these are the two plots that you want all the data points for. Browse to a location in your hard disk where you want to save it, and then click on OK. You can rename it if you want. And then go to the folder that you save it, and you have all the data points that you have saved earlier. Now, the other way of you saving data for a report or something is to save this as an image. So you can go to Print Preview. Oh, sorry. Make sure you select the right window before you. And you have a graph here, so you can screenshot this and send it as well. That's it for the tutorial.